When the USS Gerald R was announced, it represented a new era of naval ambition. A vessel designed to extend American dominance at sea far into the 21st century. Faster, more efficient, and equipped with revolutionary technologies never before used on an aircraft carrier. The Ford class was not just a continuation of the Nimitz class tradition. It was a bold attempt to redefine how carriers operated, fought, and maintained control over the world's oceans. Electromagnetic launch systems, advanced arresting gear, state-of-the-art radar, and greater automation were at the heart of this vision. The expectations were massive. For the first time in decades, America would field a carrier that wasn't simply an evolution, but a revolution. But as history would show, ambition without patience carries its own risks. And the Ford's journey from shipyard to battle-ready revealed a harsh reality behind the promises. The Ford class was never intended to be a simple upgrade. It was meant to leap generations ahead in naval aviation technology. At the core of this ambition were four key innovations. First, the electromagnetic aircraft launch system, or EMALS, designed to replace steam catapults with a faster, more controlled method of launching aircraft. Second, the advanced arresting gear, a system that promised safer, more flexible recoveries of a wider range of aircraft, including unmanned drones. Third, a redesigned flight deck aimed to boost sortie rates by nearly 25%, crucial for modern high-tempo operations. And fourth, deep automation, reducing the ship's crew by hundreds compared to the Nimitz class, cutting long-term operating costs. On paper, each of these technologies offered significant improvements. Together, they promised to transform how carriers fought and operated in the 21st century. The Ford class wasn't just supposed to be better, it was meant to be the foundation for a new era of distributed maritime operations, a new way to wage war at sea. But trying to revolutionize so many systems at once placed an enormous burden on the program. The risks were known and underestimated. As construction of the USS Gerald R. began, the first cracks in the plan started to appear. Deadlines slipped. Costs soared. Originally projected at around $10.5 billion, the Ford's price tag climbed to over $13 billion by the time it was commissioned in 2017. And even then, the ship was far from fully operational. Critical systems like EMALS, advanced arresting gear, radar arrays, and weapons elevators were incomplete or unreliable. Every delay triggered new rounds of redesign, testing, and rework. According to Government Accountability Office reports, the Navy accepted Ford with over 400 unresolved deficiencies. Congress grew increasingly impatient, with hearings focused on accountability and oversight failures. Contractors like Huntington Ingalls Industries struggled under the pressure of redesigning systems already installed on the ship. Instead of leading a smooth technological revolution, the Ford class became an example of how revolutionary ambition can backfire when pushed too fast. Complex systems that look groundbreaking on paper often failed when tested at sea. And every setback fueled a vicious cycle, more delays, higher costs, and mounting doubts about the ship's future. Among all the Ford-class innovations, none promised more or struggled more than the electromagnetic aircraft launch system. EMALS was intended to replace the steam-powered catapults of the Nimitz class with a faster, smoother, and less stressful way to launch aircraft. The advantages were real, but so were the problems. Testing revealed frequent electrical faults, including full system shutdowns mid-launch. A 2020 Pentagon report noted that EMALS suffered a critical failure roughly once every 181 launches, far below the Navy's minimum acceptable standard of one failure per 4,000 launches. In one notable 2019 trial, a failure during a critical flight deck operation halted air operations for hours. Each malfunction endangered the tempo of operations and created major risks for pilots and aircraft. Even basic maintenance on EMALS required specialized equipment and highly trained technicians, often unavailable during deployments. The Navy poured resources into upgrades, including software overhauls and mechanical improvements. By 2023, the system's reliability had improved, but many officers remained wary. A carrier is only as strong as its ability to launch and recover aircraft. And EMALS turned one of the most basic functions of an aircraft carrier into a major operational gamble. If launching aircraft was a challenge, recovering them proved just as difficult. The Ford class introduced the Advanced Arresting Gear, or AAG, to replace traditional hydraulic systems. It used complex electric motors and energy absorbers to safely stop a broader range of aircraft, including unmanned drones. In theory, it offered smoother, safer recoveries. In practice, it suffered repeated breakdowns during early trials. Failures during arrested landings endangered pilots and complicated deck operations. By 2021, AAG had required multiple redesigns and extensive reliability testing before it reached even basic performance standards. Meanwhile, weapons elevators became another major bottleneck. Designed to rapidly move munitions from magazines to the flight deck, the elevators were crucial for maintaining a high operational tempo. However, during Ford's commissioning, none of the 11 planned elevators were fully functional. Severe integration problems meant that basic testing wasn't completed until years later. In fact, it wasn't until 2023 that the Navy finally certified all weapons elevators on the Ford as operational. Without them, rearming aircraft between missions became a slow, dangerous, and inefficient process. Each of these failures pointed to the same underlying issue: new technologies deployed before they were truly ready for war. When the USS Gerald R. Ford was commissioned in 2017, it entered service with great ceremony. But in the years that followed, Ford remained mostly tied to testing ranges and shipyards. It was a warship without a war, deployed only in simulations, not in real operations. Critical deficiencies across multiple systems kept the ship from achieving full operational capability. Meanwhile, the global security environment shifted rapidly. China expanded its navy. Russia grew more aggressive. New threats like hypersonic missiles and anti-ship ballistic systems emerged. The world Ford was built to dominate had changed, and the ship itself was still trying to catch up. By 2022, after multiple delays and extensive repairs, the Ford finally conducted its first full operational deployment exercise. It successfully launched and recovered aircraft, conducted strike missions, and integrated into a carrier strike group. But real-world combat stress tests had yet to happen. Operational reliability under heavy enemy pressure remained an open question. After 5 years of delays, the Ford had proven that it could sail, but had not yet proven that it could fight. The challenges faced by the Ford class were painful, but they were not without value. The Navy quickly realized that introducing too many unproven technologies simultaneously created unacceptable risks. The Ford program demonstrated that evolution, not revolution, often delivers better results in complex weapon systems. Lessons from the Ford were directly applied to the construction of follow-on carriers like the USS John F. Kennedy and USS Enterprise. Designs were simplified, systems were modified to reduce complexity, and new technologies had to demonstrate a higher degree of readiness before full integration. Oversight also tightened. Contractors faced stricter performance requirements, and the Navy enforced more rigorous milestone testing. Meanwhile, Gerald R. Ford itself continued receiving upgrades throughout its early years. Software patches, hardware overhauls, and countless hours of testing gradually improved key systems like EMALS and AAG. By late 2023, many of the Ford's critical functions operated far closer to original expectations. Still, skepticism remains, and it will take real-world deployments under combat conditions to fully prove the Ford-class concept. The USS Gerald R. Ford was supposed to be a revolution in naval warfare. In some ways, it still is. It introduced new ideas that may eventually redefine how carriers operate. But it also exposed how ambition, when rushed, can backfire, even for the most powerful military in history. Innovation is essential, but innovation without patience, discipline, and rigorous testing can create more problems than it solves. The Ford's long, painful development stands as a warning to future generations. Technological leaps must be earned, not assumed. Today, the USS Gerald R. Ford sails the oceans with greater capability than ever before. But her greatest legacy may not be in how she fights. It may be in what she taught about how future warships must be built.